As I said, I'm here to talk about, putting the code back in infrastructure as code with Pulumi. So my name is Dan Hernandez. I'm a customer engineer with Pulumi, and I've spent most of my career working with organizations on their infrastructure as code and cloud modernization projects. So with that experience, I've seen a lot of common patterns, a lot of pain points. I've had a lot of conversations, and really that's what brought me to Pulumi. And I'm really excited to share with you today, what's possible there. And today we're just going to keep it really simple. I'm going to talk about Pulumi using like 3 slides and then spend the rest of the time demoing. So I think we have a chat function of some sort, but I think what probably is best is to take questions at the end, and feel free to, just add any questions in the chat, and I'll scroll through those, time permitting. And generally, I think it's, best to talk about what Pulumi is by talking about some similar tools that came before it, right? And really the first instance of, the new definition of infrastructure as code, not configuration management, is CloudFormation and ARM, really. And this is where a lot of folks end up when they start, especially when they're getting serious about the cloud. But the unfortunate thing with this is that, this class of tool is, of course, specific to a cloud. So there's lock-in and relearning that needs to happen if there's ever a desire to move away from that cloud, or to do multi-cloud deployments, or even take advantage of other services. And templating is challenging because, it's really verbose. For anyone who's had to, write anything serious in CloudFormation, this. And it can be hard to manage at scale. And it's not necessarily intuitive. It's, not fully expressive. And really that's where, Terraform came in, right? Which is, solves the problem of being cloud agnostic. It's absolutely a step in the right direction. And this templating syntax itself is a little bit more manageable, but, there's still a desire to, increase the functionality of that DSL. And it can be, for those of you who have used it extensively, it can be a little bit of an awkward experience. But it is declarative, which means you can see the changes prior to them actually going out, which is a great thing. And I think the last part about that really is it is somewhat architecture limited, or at least it didn't have serverless and in some cases Kubernetes workloads in mind when it was designed. And again, it is a templating tool after all, and there are all these proprietary DSL nuances that can be frustrating, especially for developers. Then there's a few other types of infrastructure as code tools and DSLs that have come up in parallel. CDK, AWS CDK is a pretty good example of this. It's cloud specific, which has its obvious drawbacks, but it's authored using real programming languages, which is a step in the right direction compared to templating tools of the past with Terraform and CloudFormation. But the not so redeeming quality is that it transpiles into CloudFormation. So it still has its foot back a little bit, and it really doesn't provide a great declarative engine experience that you would get with Terraform, for example. Then there's the class of architecture specific templating tools, tools like serverless framework. You can think of Kubernetes YAML to some degree here, Helm. There's a bunch of other like KSON. There's a bunch of other tools that are specific to different architectures. And the challenge with these tools, when looking to adopt them, or once you go beyond simple use cases, as you move into other architectures, you have to start thinking about other tools, or if you are using multiple architectures, you have to use multiple tools in concert and kind of glue them together, which can be awkward a bit, especially given a CI/CD pipeline and across multiple environments. It can be a lot to manage. And on top of that, you do have to deal with YAML. which, I'll refrain from beating on any more than our industry has, but I think we all know it's a, less ideal solution. So what, really is the best of all of these worlds? Something that's, cloud agnostic, something that's architecture agnostic, something that's declarative, and built in a real programming language. And that's really where Pulumi comes in. I think of it as the next evolution, so to speak, of infrastructure as code. And as the talk is named, I like to say it puts the code back in infrastructure as code, meaning you could define your infrastructure declaratively using real programming languages. So you don't have to use YAML or JSON or a proprietary DSL. You can use any language as long as it's JavaScript, TypeScript, Python, .NET, or Go. And Pulumi is a full engine, right? So it's a CLI tool, it's a SaaS product with the goal of making it easy for organizations or teams to adopt modern cloud technology and infrastructure as code best practices as well. And the list here is really just the differentiators between Pulumi and other tools. So with Pulumi, you get that full declarative nature of safe changes. So it's really easy to reason about your architecture and not really worry about breaking things. And that's paired with all of the power and expressiveness of a real programming language. So by default, you're getting if statements, you're getting for loops. And you have a good understanding of what changes are going to be made before you make them, right? So kind of the imperatively declarative tool, I think is kind of a way to think about it. But another big differentiator for Pulumi is that there's deep support across various architectures as well as clouds. So Pulumi has a provider model such that any API can be implemented as a Pulumi provider, but you can also, convert any Terraform provider into a Pulumi provider as well. So we're taking advantage of that part of the ecosystem. And, for the rest of these, there's, we'll talk more during the demo. I think I'll actually show some of this. And that said, really with the last one, I think the goal of Pulumi is to enable a great relationship between development teams and those who manage infrastructure. I think this is really and obviously what we've been trying to get at with DevOps and moving those two groups of folks closer, and even individuals taking some of the responsibilities from others, and the full stack teams and all of that. And it's a little bit of a funny relationship, but I think when it works out, it's a good sight to see. I think. And, with that, I think I'm going to get into the fun part and demo as much as I have time for here. Zoom decided it doesn't want me to change slides. All right. So, what I'm going to do is, there's a lot of stuff that you can do with Pulumi. As you can see on this slide, there's really just a whole lot of different use cases that I could show you. But today I'm going to focus on AWS. I'm going to show you like the container architecture there that we put together. And I'm going to write my code in TypeScript. I'm going to use GitHub, or I'm going to try and use GitHub successfully on a live demo, set all that up. And we'll see how much of the advanced stuff that we get into. I should be able to get to policy as code, maybe touch on components, and we'll see about secrets. And again, please put questions in the chat below, and I'll scroll through those and answer what I can at the end. Quick questions. Anybody know why I might not be able to click through? Okay, never mind. Seems my setup wants to block my pointer here. So what I'm going to do is I'm going to start by creating a, it's doing it again. a Pulumi program. And to do that, I'm going to start with a fresh directory. I'm going to call this a new app. And I'm going to run the Pulumi new command. So by default, you can see there's all of the different languages and things that that I'm showing you here on the left as templates. So it's really easy to get started. But there's also a way to create your own templates, which I'm actually going to take advantage of now. What is going on here? There we go. So I'm going to use a GitHub repo that I've put together, which you can also point at. And it's going to ask for a project name, and I'll go with the default, which is just the name of the directory that I'm in. It's going to ask for a description, and I'll go with the default. And it's asking for a stack name. So this is something that can confuse folks that start with Pulumi, so I'll take a moment just to talk about it. So a stack is really a implementation of a program or a project. The most typical layout is development, staging, production. So multiple instantiations of the same config using different parameters, essentially. And when I create a new project, I'm going to start with a single stack. And that stack here, I'm going to actually name local. So this is what I'm going to be running on my local machine here. And because this is an AWS application, it asks for a region, and I'll go with the default.
Hey, Dan, just quick thing. Can you move your terminal a little up, the whole thing? Just because, yeah, it's a few things. Yeah, that's good enough.
Okay, cool. Yeah, I'm going to put some stuff up top here, so I'll kind of go back and forth here in a minute. So yeah, what that did is it pulled down the source from the repo here on my left, and it ran npm install. So the Pulumi project is ready to go. And I will open up Visual Studio Code, and we can take a look at what it's generated here. All right, so there is the index.ts folder. This is really the entry point to any Pulumi program. And this is where you can declare your infrastructure. So in this case, you can see it's a pretty simple example. It's an S3 bucket, and it's using the AWS library, which includes the full surface area of AWS. I'll talk a little bit more about this in a second here when I do a little bit more of an advanced example. So I'm going to go ahead and run this, actually. And one important thing to touch on is this is real code, but it's building a state, and it's building a graph of the resources that I'm intending to deploy in my environment. So with that, I get an opportunity to see what the changes are before I actually make them. And you can see here, it's looking to create a single bucket. In this case, I will say yes. And what it's doing is using the AWS provider that's part of the CLI that's been pulled down to call out to the AWS service. So all of the secrets and the configuration for calling out to the cloud is either local or in a CI environment. You can see we have an update here. And now what I'm going to do next is kind of just get more into the example. And I'm going to copy over some code here. You can see index is the entry point, and unless I import any of these other files, they won't actually make it into this file. So I'm just going to use these as kind of an easy way to pull in new pieces of functionality quickly. So what I'm going to pull in is a Fargate service, an ECS, and a load balancer. So this is a fully load balanced application. It's a really simple example. It's using the image from AWS's ECS tutorial. And we'll go ahead and delete that. And I'll run this. So, a part of this being declarative, you'll see that, I'm not looking to create an additional bucket here. It will know that the bucket has already been created, and it will go ahead and create these resources. And you're also probably noticing that there's a lot of resources here. And even though I just, declared two, just a load balancer and a Fargate service, if you're familiar with these services, you know that it's not actually that simple, right? There's a lot there. And this is where the power of this AWS X package comes into play. This is an example of a Pulumi component that allows you to abstract the AWS or any of the other cloud infrastructure packages. So here you can see it's creating the actual load balancer, which is ingress, egress, the target group. It's creating the actual ECS services, security groups, the roles that are needed, the actual VPC and some subnets. So it's creating a lot of resources with very minimal code, which is one of the benefits of using a real programming language is that it's really natural to create these abstractions. And actually, I'll let this run because it's going to take a few minutes, and I'll show you what this looks like. So this is our AWS X package. This is been developed by Pulumi engineers, and I think that its largest value is as an example, because many organizations are going to have their own implementation of this, and they're going to have their own nuances of how they want to deploy ECS and any of the other packages. So if I dig in here, you can see, we've built components for a lot of various AWS services. In this case, we're using ECS, and we're using the Fargate service component. And this actually, uses aspects of, real programming, like extending of classes, right? Using, composition and inheritance. You can do that. And in this case, it's using a task definition component resource that we've declared. So this is actually fairly complex because we've designed it with a large amount of users in mind. But let me show you an example of what this would look like for a more simple use case, right? And this is actually the code that we have here, right? So it's the bucket and ALB and a Fargate service with all of these different components under it. So I'm using those, I'm pulling those in, and I've essentially just extended this component resource class, implemented the constructor. This is really where everything happens is within the constructor. And I've passed along a few variables, and I've declared the resources here. And what this results in is this. So building that component, I can now even further abstract this architecture such that it's only a single line of code. So you can see the power in this in enabling that relationship between the developers and operations folks, people who are really adept in infrastructure in the cloud and those who are not, right? So being able to essentially package up things such that it feels like a pass almost, right? You can get to that level of abstraction, and everything in the background can be deployed into various package repositories. So in this case, our AWS X package is in NPM. For Python, they would be PyPy. So just the respective package managers, you can store those things. And of course, the problem of versioning and management and reduction of copy and paste has been solved for those package managers for a really long time. Let's see, it's still running here. I think it's waiting on the load balancer here. One other thing I can talk about actually is policy as code. So when this comes up, I'll actually create a Pulumi policy, and I'll show you some capabilities around being able to enable security teams or security focused development teams, and writing rules such that you can peek into the infrastructure and understand what's being deployed, and making sure that it's following best practices for compliance. While we wait, I think it's almost done there. I'm going to go ahead and create this new Git repo because I know we're going to need it. I'm going to call this new application, make it public. One other thing I can talk about actually in the meantime is something that's especially unique about Pulumi, which is the ability to manage secrets. So typically with an infrastructure as code tool, you have to bring up Vault or have a manual intervention within a CI or CI process to make that happen. With Pulumi, you get secrets kind of right out of the box. So in this case, if I wanted to, you can see by the example here, if I wanted to create a username or let's say, a password, we could do that and then mark it secret using this additional secret outputs. And this will make it such that in the state itself, it will be secret. And you can also take advantage of that same encryption mechanism to set secret config values as well. And this is pluggable. So by default, Pulumi will create a key for you and then encrypt and decrypt these things at the CLI. But if you wanted to provide a key from Vault or KMS or any of the other encryption providers that we support, you can do that as well. So it's really integrated process there. So this took, about 5 minutes to deploy, and that's pretty good given it's creating a load balancer and all of these resources. And what I'll do next is I will set this up in a repo. So this isn't really how things typically work, right? It's just, we don't get to just make it work on our machine. Let's see how this would run in a real, production-like scenario. So I'll update this script here a bit. Actually, we'll keep that. And we will run this. So this will push our Pulumi project into this GitHub repository that we just created. I should be able to refresh this and see the code there. You also notice that I've integrated this with GitHub Actions. So in my template itself, I put some default config files for pull requests and push. So on my first commit to this repository, I'm getting a CI run going, and it's going to actually, in this case, actually, one thing I forgot here is to create a couple new stacks, which I'll do now. So this actually won't run, but what I'll do is create a new stack that I'm going to use for the master branch. So this is going to be production. So this is a completely different config compared to our local instance. So the local I really like to think of as just your place to play around and while you deploy changes into a CI environment where you can have your CI job doing the right things and deploying to the right environment. So I'm going to do a set the config value for the region. I'm going to make this go to US East 2. It's a little bit safer there. And we'll add this file here and push it up. So on this second commit, we'll see a new run happening. And in this case, the reason for this nuance is I've set up, and this is specifically to Pulumi GitHub actions. We have a integration that we've built to make this really easy. That's using the Pulumi actions Docker container. So with that, we can set some config variables where we can map the branch to the stack that we're going to deploy. So by default, I've set up two values. Master goes to production, and then feature branch obviously goes to feature branch. And as you add more branches, you can update this list as you go along. And while that runs, I'm going to show you policy. So I'm going to create a new directory. We're going to call it policy. And this directory is actually, if you missed that, I put it next to our application. So it's outside of the application. So we'll go back into that. And we'll do a Pulumi policy new. And again, there's a bunch of different templates available for creating policies. In this case, we're going to go with AWS TypeScript. It's doing a similar thing. It's pulling over the templates and running npm install. So all of the dependencies are available. And I will open this up as an additional VS Code window. All right. So here, this really simple policy, now I'll make this a little bigger so it's easier to read. The way this is written, you can see this is real code. Again, with Pulumi, everything is code based. So this is true policy as code, where essentially you create a policy package, which includes a list of policies. And the default policy that is created with the AWS TypeScript template is the S3 no public read policy. And what I'm going to do actually is split this up between two different policies. So This is going to be looking at both public read and public read write. I'm going to split this into two policies. And basically what Pulumi will do is it will look at any resources with this type, and you're able to validate that resource by using simple if statements, right? So anything that's available in that programming language, you can use to evaluate the architecture of your application. So there's not a lot of nuances there outside of the specific syntax here, which I think is similar to unit testing syntax, right? So you have this arbitrary callback function that if there is a violation, you can report it. And for this one, it's mandatory, and I think that's why we're going to split this out into two. And make it public read one and public read write a second one. Get rid of this. All right, I think we have that set up properly. And one other change I'm going to make is I'm going to allow public read, but I'm going to just advise anybody who is going to deploy applications that this isn't a great pattern, but I'm going to enforce that public read write is a bad pattern. You can see here on the left that GitHub Actions was actually able to fully run this application, and we can grab even as an output here the result of that. You can see this is a simple PHP app, again, part of the getting started guide for ECS. And let's move on to showing a little bit more about policy. And then I'll wrap it up. And I'm sure I've kind of whirlwinded around a lot of different topics, kind of on purpose. I'll open up for questions right after. So I'll move back to my original folder for my application. And what I'll do here is make a change to the code such that the ACL is public read write. And then we'll try and run this again. In this case, we're going to put in a policy pack flag that's going to point to this policy folder that we've put together. So what we should see is the ECS cluster and service and load balancer should already be deployed, so there should be no changes required there. But we did make a change to the bucket, so it should recognize a change to the bucket and also fail because we've violated a rule that we've written, and you can see that happens here, right? So as you can see, prohibits setting public read or public write. And it blocked it. Oh, did I save? 1 second. Maybe I didn't save because it looks like I thought I changed that message. Oh, I didn't save it. Okay, that's fine. It still blocked it. Having trouble with Zoom here. Okay, there we go. All right, so I've saved that. And And if we run it again, we should see the updated message, and it'll be specific to public read write. Then I'll run it again, and I'll change this to public read, and we'll see that it'll succeed, but it will warn us that it still violates, or at least does something that's slightly not compliant. So we've got the updated message, prohibit setting public read write permission. Let's go ahead and update this to public read. Rerun it. So it was successful, but again, there's an advisory message here saying that this is, inform me that this isn't a best practice, but we'll still allow you to do it. In this case, I'll go ahead and deploy it. So that's that. I think a few things to note here is obviously you'll see that I'm using a flag, and of course you can expect folks to just not use that flag and then go out of compliance, right? So with Pulumi, part of the SaaS product is you're able to manage these things centrally and make it such that any Pulumi stack within an organization can adhere to a set of policies. So you can, here I don't have any set up as default, but I could come in here and add a policy pack to my organization. And in this case is taking advantage of some more advanced features with policies code, which means that you can create more generic policy packages and make them able to be configurable. So you can create multiple different packs with different configuration values here. And the way you would deploy this up is through the CLI in that application or in that policy folder that I showed before. So I think that's all I have for today.